Okay, let's see if this works. So the first thing I need to make sure is that I actually am streaming. There we go. And then if this works. Okay, there seems to be some kind of audio, that's good. So what I want to do today, let's where do I write this? So what do I mean here? So there is Huggingface, it's a website, and you can, I think I might just take it down here to write on it. So we have huggingface.com, and it's mostly based on PyTorch. Huggingface is a company, and they are hosting a bunch of parameters for transformers, and so it's built on PyTorch, and it's a library for deep learning. It can be used to do all the things with auto differentiation, training of models, and so on. So they built this library called transformers. It is a Python package, and within there they have a bunch of different transformer architectures, including one that's called Qwen. And Qwen is a Chinese company that builds, it's by Alibaba, the big IT company in China, and they build some models that are open source, so their weights are on huggingface.com, and the exact architecture, the way that you use the MLPs, the attention, all the details that make it a special model, because even though you might learn some things about self-attention or feed-forward networks and so on, all models are kind of different, and that's what research involves, that they find interesting ways to make it work better, to make it train better, etc. So Qwen has some models, and let's just imagine now that transformers is the blue thing, and then up on Hugging Face they have these weights, they're the red ones. And what we can now do in Python is we can import I don't know what's red, import transformers, and then we can in a way say something like model load pre-trained. So let's say import transformers.load pre-trained. This is very simplified. This is just some kind of pseudocode. So import transformers load, and then we load the pre-trained model that's called Qwen3. And then a specific size. They have different sizes of language models. Some language models are smaller, some are bigger. That means they have more layers or more parameters. So I will use a very small one, 0.6b. And what will now happen is that in here it will then create this model. That's some code, and it's in here. So in here, and then it will go to the web and find the red thing, and this will be the model. And then you can do something like next token is equal to model dot get next token for hi, how are, etc. This is again just pseudocode, and you can get the distribution of all the things. Now that's very cool. The thing that I'm gonna do is that there is the other library, Jax. And Jax is something that is originating with Google. It's an open source, and it has an ecosystem. So it also has this thing called Flax and Optex and all these other libraries that can be used for neural networks and deep learning and autograd and everything. And it is in some ways like a mix of a bit of a level of NumPy and PyTorch and so on. And what I am now going to do is I am going to look at, so there is this thing called Gemma, and Gemma are some models by Google, but they also have an open source repository where they implement in Flax or something called Cauldron, a kind of mix of some Jax-like technologies. At least they have Gemma, and this is a library where they do kind of the same. They have some kind of the architectures defined in the code, so you can do something like import Gemma, and if you install the Gemma library, and it also has something like Gemma is equal to no, that's actually what they do not have, and that's what is very cool often about Flax, even though they're kind of going away from it sadly. It's something like you have the parameters, and then you can say something like Gemma dot download weights for Gemma. Maybe they have something called 1 billion parameters. So they have some parameters. They were trained by Google, and then they download the parameters, and then you can say like next token, and you can say maybe model is equal to Gemma dot Gemma 1b. So this is like kind of the box, and this is the parameters, and then you can get the next token by something like Gemma dot maybe model dot get next token of what, of hi there. But you can also take the parameters. They call it params here. So they have a bit more split up, and in many ways Jax is an interesting framework for the stuff. The transformers library, it has to accommodate a lot of transformers. Very many companies are building their own transformers. They want it in there. They have a lot of different use cases, and therefore the transformers library is very big, and it's in a way like very object-oriented programming, and Flax is a bit more kind of functional programming. It's still in Python, but they have some stuff there, and that makes Jax a bit more satisfying to me to work with, and it's still also an important part of the whole deep learning ecosystem. So I think that's the reason why it can make sense to do this. And there are some Jax implementations of stuff out there, but yeah, just to learn and stuff, then we're gonna do it from scratch, but not fully from scratch, because what I want to do is this Gamma library. It's made by software engineers at Google and software researchers, AI researchers. So it's quite good code base, and it uses Cauldron, which is their library in the Google GX ecosystem, to train also stuff. So a lot of this code is quite high quality, and it would be cool to do something like Gamma Qwen. So what I'm gonna do is I already have the repository for Gamma, and we're gonna use that together with the Qwen codebase on Huggingface, and then we're gonna download the weights here and just have the model working. But we're also going to then use some code from Gamma to kind of be the basis for our implementation of it. And in essence, what we care about is that we have some way of downloading from Huggingface the weights and turning them into some kind of weights here. And that's one problem. Maybe there's some difference. Hopefully not. The matrices are just matrices, right? But there can be still some details. And maybe they should be the other way around or something. And then we have some Huggingface architecture that will be our reference, and we want to turn it into something so that we can now in the end plug them together, the architecture in PyTorch and Huggingface PyTorch, and apply the weights, and they will be equivalent in terms of maybe just for the beginning, like, hi there Bob, hi there, how are you doing? That we predict the next token with a similar probability distribution. So we want something like this. And this is probably going to be a big task, so we'll just break it down and start looking first if we can get the transformers working on my machine. Qwen, I did it before a bit, so it should be possible, and then we will go on to looking at Gamma and think about how we can adapt it. So I'm just gonna check first that my channel is still live, full, and then we will go on to okay. So set up here. Okay, so what I first do is I go to projects, and then I will have to activate my environment that I often use, and let's say Qwen Gamma, and then I see if I have some Gamma, and I have transformers. Yes, I do. Okay, then I am going to open up a file here, and the first thing I'm gonna do is just to git init it, and then I'm going to say explore transformers Qwen. So just to make sure that we can kind of generate a probability distribution from hi there. So purpose of this script is just to check that we can download Qwen 0.6b from Huggingface transformers and get next token for Okay. So, how does this work? Well, I have already some code that I used a while ago. It's this one. So we're just gonna do that. So from transformers, import also organizer and also causal or model for causal language, like that. And then with these cells I can kind of do a bit of Jupyter notebooks inside my file, and that works. And then I am going to scroll down here to some code that you can often find here. So Qwen 0.6, let me just show you. This is Huggingface, the website. They have, it's a bit like GitHub. You have some organizations and users, and they have these almost like repositories, and they will show you also here how you download some stuff. So let's just use this. You're defining the model that you want, the name of the model. Then you say tokenizer. A tokenizer will help you go from a string of text onto these tokens, these IDs of the words, and also go back. And then now I said we are going to say, let's go and fetch this thing from Huggingface, the pre-trained one. We're gonna fetch the weights that Qwen, the company, they trained it, and inside Auto Model for Causal LM, they will look for the exact architecture that we need. So if we go in here in the files and versions, it will go and it will look at this config.json, and it will say the architecture, the blue box that we were looking at, which one does it have to be? Qwen3 for Causal LM. So it is in there somewhere. Let's say transformers. So inside Transformers library, they have some folders: source, transformers, models, Qwen3, modular Qwen. So, and in here they have a class that's called Qwen for Causal LM. It does not need to implement all that stuff because it's the same architecture as Qwen2 for Causal LM. So they somehow did two, maybe just for good order to not get confusion. And there they have some more stuff about how exactly the forward pass is working, all the details. And yeah, great. So then, for example, they describe the architecture, blah blah blah, how many attention heads do we have, what is the activation function in the feed-forward network, what is the residual stream, dimension, and all these things, and also which kind of data type are the parameters stored in, and how many tokens are in the vocabulary. So there's 150,000 tokens. And this is probably actually what we're going to start with, trying to port to checks. But now we get this model, and it is going to download it from Huggingface, and I already downloaded it before, I think, so that's why you do not see it downloading. And when we just look at model. Now we have the architecture here. It's a model. It has an embedding layer. It has 27 layers, 28 layers, and in each layer there's a multi-head self-attention module with projections and all this stuff, and an MLP for feed-forward network. And you see we have two affine transformations up, and then you apply a combination of just the output and activation and apply activation to this gate lid, and then you apply some layer normalization before this Qwen self-attention module and post-attention, and then you apply all these layers and do an RMS norm in the end, I guess. And we have rotary embeddings that we will apply in general, because there are no parameters in the rotary embedding implementation. And yes, so luckily all of this is very modular. Usually with deep learning is almost like, not inherently, but most deep learning models are modular, and especially transformer is, so we don't need to build everything at once. But now we just have to go and fetch the parameters. So we have let's say model, model.forward, and the model.forward takes, I do not know why I do not have IntelliSense here. Yeah, it's right. They have a chat template. Yeah, let's go through that first. So we have some tokens. Hi there, but I said like hi there. This hi there is not the beginning of the string, because they trained the language model to be a chatbot in a sense, and therefore they have a specific format where the tokens are actually something like system prompt, roughly like system prompt, yo, you are a chatbot, and then it has user colon hi there, and then the assistant will say hey. So what we need to do then is to do that, and so this is the prompt, this is the message. I'll just do like this: role user content hi there, and I will then use this. Do we need to do anything to do? No. This is then something that Huggingface made, that they say, okay, I'm ready to make this into a thing. So now you can see. Here we started. The user says hi there, and then we end that part, and then we say assistant is ready. This is what I said here, hey, and we're gonna see if it says hey. So how are we gonna do that? We're gonna take the tokenizer and use it with a list. So this is just a string. We're gonna be able to tokenize many things and return tensors model.device. This is not so necessary right now. I'm just on my laptop. And then we have some tokens. So this is IAM start is this one, user is this one, new line is this, hi is probably this one, and we can of course only guess unless we memorize a lot, but this is the idea. And now we can forward it through, and here they have some stuff where they are generating text, and I don't want to generate text, I just want to kind of get the output of the model. And I think I'm just gonna ask so it says model now it's going to do a forward pass, and what does it say? It says I have a causal LM output with the past. That's good. And the ones I care about are the logits. These are all the ones before we apply the softmax that gives us a specific distribution over the tokens. So what does this mean? It means I have one sequence I've forwarded through, right? I could also have had another. I could say hi there. So they will take this string that we saw before. This is an actual formatted well string, and a badly formatted string where we do not use the right tokens to make it into chat format. And then we get the oh, we couldn't do that. We should probably activate truncation or padding with padding true. Good. Padding is the idea that this string is longer than this string, but we want that it should be a matrix that should be inputted, right? So input IDs and attention mask. So the model inputs, it has a tensor, and it is input IDs is this one. It has a certain shape, and this shape is 2 times 10. There are 2 strings and 10 tokens, and here, because there were 10 tokens in the first one, in the text, the right text, we are going to add padding tokens to the end, and apparently this padding token is 151643, and you're adding them. Say hi there, pad. And this is also why they say attention mask. We do not care about the last tokens. We should not train on them in a sense. We should just make sure that they have the right format. And now, because we want a matrix going in, this is why they require that. And now we have an output being 2 sequences, each with 10 tokens. And for each of the tokens, we have a prediction for the next token, 15163. And then I'm going to look at outputs.logits, and I'm going to use the second sequence, and the first token 0 1, so it's 0 indexed, 1 hi there. It's gonna predict what is gonna be next. So we're gonna say this, and this will have 151,96936, this many. Great. So this is hi there logis, hi there logis, and then we will have some token that's the most likely, and we can then use the tokenizer, and we are then decoding. Hi there, new line. Okay, that's a bit boring. Hi there, how are you? Because we're now looking at the wrong thing. We should look at this one. You can see here 0, oh, yeah, 0, 1, 2, 3, 4. 4. We divided the text into 4 tokens, and therefore I'm gonna look 0, 1, 2, 3, 4, what it is saying here. 11. How are, comma, you? Okay, that's a bit interesting, but it also might make sense. Let's look at then the last one also here. What is the chatbot saying? The chatbot should respond to the text, so it will be oh, it's actually the first. I'm doing it wrong. Yeah, let's just say, because we have 2 sequences, text and so on, this is the logits 1.4. It's actually 948, so I'll just take the like that. How are you? So it will predict how are you, and that's great. And also if we try the text instead, then it will be 0 and -1. Thinking. It will start thinking because it's a reasoning model, and it will then start thinking, and it will say, oh, the user is thinking that they want to greet me. I should probably greet you back. So I will say, yeah, it will say something. Good. Now we have everything we need. We have a working inference, and the first thing we want to do now is to think about the how we're gonna port this. So let's just think we should do another script. I think it's unrealistic that we can actually build the, like, change the code base for Gamma. So we will instead do something else where we are just copying some of the code that we need. But yeah, let me just take a little break. How is it going here? Just copying some of the code.